Hello, and welcome to today's Pedestrian and Bicycle Information Center AASHTO Bike Guide Series webinar. Today's webinar is titled On-Road Facilities Part 1, Bike Lanes. And we will be speaking with Bill Schulte, Senior Engineer at Tool Design Group, and Nick Jackson, Senior Planner at Tool Design Group. My name is James Gallagher, and I am the PBIC Communications Manager. I will be facilitating today's webinar. I'd first like to say hello to today's speakers to make sure they are ready and that everyone can hear them. Bill, are you there? And Nick, do we have you on the line as well?
This is Bill Schulte. I'm here.
And this is Nick Jackson.
This is the third of 7 webinars on the AASHTO Bike Guide. For more information on those and other future webinars, or to view the archives from this webinar series and others, please visit www.walkinginfo.org/webinars. In addition to these webinars, PBIC offers 4 different in-person training courses to provide technical assistance to professionals and community members in developing pedestrian safety action plans and improving conditions for walking. These courses can be found at www.walkinginfo.org/training. Before we start the feature presentation, I want to take a quick poll from the audience. All right, thank you very much. Okay. I'd like to welcome and thank Bill and Nick for their presentation today. We'll take questions at the end. Bill and Nick, please take it from here.
Great. Well, thank you very much, James, for the introduction. And good afternoon to everyone listening in online. It's a pleasure to be here today presenting on the new AASHTO Bike Guide. And again, my name is Nick Jackson. I'm a Senior Planner at Tool Design Group. And I'll be presenting with Bill Schulte, an engineer at Tool Design Group. So I'd like to mention that you can follow the presentation today on Twitter. You can follow us on Twitter at Tool Design. If you want to tweet your own comments, you can add the AASHTO or Bike Guide hashtags. So I'd like to give a brief introduction to today's presentation. This is webinar number 3, and we're focusing today on Chapter 4, which is on-road bicycle facilities. And this is part 1 of 2 presentations on this chapter. In today's webinar, we're going to focus on significant updates and new content in the guide. This is an overview. There is a lot of nuance, a lot of detail in this chapter. So even with 2 webinars, every detail can't be covered. We want to talk about the major changes and the major highlights in this presentation. So as a reminder, this is the overview of the webinars. This is the 3rd webinar. Today is September 4th. On September 18th, we'll be doing the 2nd webinar, looking at Chapter 4, on-road bikeways. And then in October, we have 2 webinars focused on shared use path design. And then November 6th, a webinar on bikeway maintenance and operation. So as James mentioned, there was a discount on the new AASHTO Bike Guide for webinar participants. As he mentioned, you will be emailed the link shown on screen here to be able to redeem the discount on the new guide. And I know in the past there were some bugs in that, but it looks like all of those have been worked out. So I'd like to give a little bit of background on the guide and some context. So first of all, the mission of AASHTO, and AASHTO is the American Association of State Highway Transportation Officials. And the mission of the organization is to provide technical services to support states in their efforts to efficiently and safely move people and goods. That's the core mission of the organization. Looking at the history of the bike guide, the last guide was published in 1999, and it was largely written a few years before that. in preparation for this new guide, there was a survey that many of you might have taken, that was done in 2004 to help develop the scope for the new guide and what issues the new guide needed to address. So it's really important to note that the bike guide is guidance as opposed to a standard. The bike guide does not use words like shall, use words like should or may, and that's a very important distinction. The AASHTO guide also is closely linked to the MUTCD, and it's very important that the AASHTO guide does not get out in front of the MUTCD and instead refers to devices that are already included in the MUTCD. And finally, it's also important to note that due to the nature of AASHTO, that it's important that the guide apply to a wide variety of contexts. So we can also look at how does the bike guide relate to other manuals. As I mentioned, signs, signals, and pavement marking information in the latest edition of the MUTCD related to bikeways have been incorporated into the 2012 AASHTO Bike Guide. So those two are compatible. The AASHTO Green Book in general refers to the bike guide for bicycle-specific guidance. In terms of accessibility, the new ProWay guidelines have also been incorporated into the 2012 Bike Guide. And then finally, the Highway Capacity Manual includes new multimodal level of service, including bicycle level of service, that is also reflected in the Bike Guide. So another question is, how does the AASHTO Bike Guide relate to the NACTO Bike Guide? And I'll make a couple of points. The first is that the AASHTO Guide is a comprehensive manual. It covers all aspects of bicycle planning and design, both on-road and off-road bikeways, including fundamental operating characteristics of bicyclists and geometric design. The NACTO Guide is not intended to be a comprehensive guide for geometric design of bikeways. Just one example of the difference is that the AASHTO Guide explains in detail how to calculate stopping sight distance for bicyclists. The NACTO Guide does not include this. And calculating stopping sight distance is a fundamental operating characteristic that any engineer must know in order to design a bikeway, including innovative facilities like cycle tracks. So rather than focusing on all types of bikeways, the NACTO Guide covers certain types of on-road bikeway designs, specifically bike lanes and other new and innovative types of on-street bikeway treatments. The NACTO Guide does not cover shared use paths, signal design, and many other relevant topics. So it's not really a question of either or. Cities looking to build innovative bikeway designs correctly should use both guides. So just a quick reference to the AASHTO Green Book is that streets that are designed to meet the basic design principles of the Green Book will generally accommodate bikes by providing adequate sight distance, vertical and horizontal curves, as well as cross slopes. That's the picture of the cover of the current AASHTO Green Book. So I just want to give a few basic definitions that we'll be referring to where the Bike Guide draws from the MUTCD. These definitions are important for our discussion today on bike lane types. So I want to talk about the different types of lines that we use to design bike lanes with. Solid lines discourage crossing. Generally, their 4 to 6 inch lines are considered normal width. Wider lines are generally 2 times normal width, and they can be used to add emphasis. Double solid lines prohibit crossing. And then finally, dotted lines provide guidance or warning where crossing may occur. So a quick mention of green-colored bicycle lanes. The AASHTO Bike Guide, in addition to including items in the MUTCD, also includes items that have received interim approval in the FHWA. And that includes green bike lanes. This is a screenshot of the memo giving interim approval to the use of green color in bike lanes. And it notes that in marked bicycle lanes, an extension of other bike lanes through intersections, other conflict areas, green colored pavement may be used. That's an important note that the AASHTO Guide includes green colored. And we'll talk more about that use in a moment. So here are two common examples of, or two examples of how green colored pavement can be used. On the left, we see the use of green pavement to highlight the extension of a bike lane through an intersection where there are conflicts. And the right, we see the full, a full bike lane drawn in the color green, and that can be useful where there is a concern about parking in the bike lane. So I'd like to give a summary of the major content changes in Chapter 4, and for the focus on new bike lane content. The guide includes extensive discussion of the value of bike lanes. There's also much discussion of determining bike lane width and the nuances of when to use different widths. And we will go into that in detail later in the presentation. Climbing lanes are also included, a discussion of on-street parking, intersection guidance, as well as retrofit strategies. So one important change I'd like to highlight here regarding bike lanes. The 1999 guide included this statement that was often seen as the stated preference for wide curb lanes over other type of facilities. I want to compare that to the current guide that includes these two statements. The first one is important because it recognizes that wider curb lanes can often have the result of increasing motorist speed, and this can be detrimental both for level of service for bicyclists as well as pedestrians. And it also includes the statement below that bike lanes are the appropriate and preferred bicycle facility for thoroughfares in both urban and suburban areas. So this is a significant change in the guide. So some of the major content changes in the current bike guide include other innovative designs. I've mentioned green bike lanes. It also includes discussion of buffered bike lanes, CONTRA-FLOW lanes, climbing lanes, as well as accommodating left turns for bicyclists, and then designing bike lanes around angled parking. So the chapter begins with the discussion of some of the basics for bicyclists and how that impacts design decisions. I want to highlight some of the key points the guide covers. The first is the important observation that bicyclists have the same access and mobility needs as motorists. We also acknowledge that crashes in urban areas are the highest at intersections. Also, bicyclists vary. Bicyclists have different operating speeds, and their acceleration rates vary, as well as varying significantly from other types of road users. Bicyclists are also very sensitive to traffic speeds, volumes, different types of terrain conditions, and therefore lateral separation, the amount of separation from conflict, is very important. Finally, this feeds into the last point that bicyclists are vulnerable roadway users, and that needs to be taken into account when we are designing on-street bicycle facilities. Taking that information, just some of the basics of bicycle lane design, that bike lanes allow cyclists to choose their own operating speed. As I mentioned before, they are preferred over shared or wide outside lanes. Bicyclists also, we know, prefer bike lane continuity. And finally, they are sensitive to adjacent traffic volumes and speeds. That sensitivity needs to be taken into account when we're designing facilities.
Okay, so I think it's important that Nick made the mention at the beginning that this is a guideline. It's not meant to be a standard. And with that, any guideline cannot possibly detail out all the various scenarios that we would encounter in the roadway environment for the real world environment. As such, engineering judgment is critical to be applied to develop appropriate context-based solutions under a variety of situations. So the purpose of the guide is to provide you the overarching principles that when you encounter unique situations, you can apply those principles to develop unique solutions. So the first and foremost question is the width of bike lanes. Width of bike lanes should really be a context-based decision. And the measurement of those bike lanes is to the centers of the line. The preferred bicyclist operating width is at least 5 feet, and it's illustrated in this graphic from Chapter 2. And I think it's important that the guide be written in its entire context, that you're considering the operations of the cyclist and the user and how they fit into the roadway environment. So we discussed that chapter at the last webinar. This is a new graphic in the guide. It's an update of the older graphic that just showed bike lane widths in various contexts. An important point I'd like to make with this graphic is that we're showing different dimensions for parking lanes and bicycle lane widths. And again, it's to reinforce the notion that solutions should be context-based, and that it's not always necessary to have a 5-foot bike lane or 8-foot parking. I'm going to walk through the various scenarios that you would be considering bike lane widths under. First one is an open section roadway with no gutter, no curb. And in those situations, the bike lane should be 4-foot minimum. Under bike lane scenarios where there's no gutter, but with a curb line, but it's you have no parking, bike lane should typically be 5 feet in width. And under very constrained situations where all other travel lanes have been narrowed, the guide speaks to an allowance for a 4-foot bicycle lane. And again, this is a situation where there's no gutter line. The guide also makes frequent references to the value of additional width to improve the comfort and safety of the bicyclist. Next iteration that you'd consider is a bicycle lane against the curb where there is a gutter line. There's two situations that are pretty common throughout the United States. The first is when you have a 12-inch or a 1-foot wide gutter pan. In that situation, the bicycle guide recommends that you have 4 feet of clear width to the left of the gutter, so a 5-foot total width measured to the face of the curb, to the center line of the bicycle lane stripe. Second common situation throughout the country is a 2-foot gutter pan, and in those situations the bike guide makes the recommendation that the bike lane should be a minimum 6-foot width. And again, re-emphasizing the points I've already made, additional width can be beneficial. Whenever you have a bike lane against a curb line, there's often drainage structures and conveyance systems. The bike guide speaks to this in a couple of different sections, but as it relates to bicycle lanes, it makes a couple statements that it's important to consider that usable width of between the gutter line and the bicycle lane stripe, and that usable width should be 4 feet clear. It also talks a lot about the effect that a drainage gate can have on the bicycle rider, and that they may be inclined to swerve around it to avoid it, and that again is a reason for having it, striving for a 4-foot clear width between the edge of the drainage grate and the bike lane line. And lastly, the critical point is to make sure that you have drainage grates that are compatible in the event cyclists do ride over them or have to ride over them. And in the event that you're doing some planning or design, it makes statements that every effort should be made to relocate drainage basins out of the bicycle lane or to retrofit the grate. The next very common scenario is a bicycle lane adjacent to parking. For the old guide, the bike lane width at a minimum continues to be 5 feet, but now there's some additional discussion that I think is a little more clear than the old guide. The old guide allowed wider bike lanes, but it kind of referenced it in a non-direct manner. Now it's a lot more direct in suggesting that 6 or 7 foot parking, 6 or 7 foot wide bicycle lane is preferable when you're adjacent to high turnover parking. It suggests that wider lanes are definitely important for the bicyclist safety, and that you can also narrow the parking lane to 7 feet. When a little bit of nuance with this is when you have a combined bike and parking lane where you don't mark the parking lane line, it suggests a minimum distance of 13 feet measured from face of curb to the center of the bike lane stripe. Situations where the parking turnover is much lower, the bike guide still allows you to mark that line at 12 feet. It also makes an allowance for marking the line at 12 feet if you mark the parking lane at 7 feet. The guide, for the first time, has some discussion relevant to dooring in narrow bike lanes next to narrow parking lanes. It's a concern that's of importance, especially in urban areas where it could be a crash type that can cause serious injury or even fatalities for cyclists when a motorist opens their parked car door into a moving bicyclist. The guide suggests a number of different strategies for mitigating this concern, where one being obviously wider bike lanes is acceptable. A second strategy is to widen the parking lane. The photograph on the left-hand side shows you a wider bike lane inclusive of that buffer that you see. The cyclists have the ability to function anywhere in that space. The picture on the right-hand side actually shows a much wider 10-foot wide or more parking lane where the bike lane is striped to the left of that. Other options that are discussed in the guide are to add a buffer to the door zone itself, to the space between the bicycle lane and the parking lane, as shown in the photograph on the left-hand side. And yet another option that was based on some research from San Francisco was to actually take a standard parking tee and extend it out like a cross into the bike lane to the width of the potentially opening door, as shown in the photograph at the bottom right. Another option that is put out in the guide is discussing the use of narrower bicycle lane symbols, as shown in this photograph, which are a little bit smaller and positioned on the left-hand side of the bicycle lane to encourage cyclists to ride closer to the left edge of the bike lane line. The AASHTO Bike Guide also discusses, has some additional discussion and expanded discussion on bike lanes adjacent to angled parking. It has a statement that's fairly strong that bike lanes should not normally be placed adjacent to conventional front-end angled parking, primarily because the sight lines are not very good between the motorist who's backing out of that parking space and the cyclist. Additionally, for the cyclist, it can be difficult to see a motor vehicle that's blocked by another motor vehicle backing out into the space, potentially resulting in a collision. That said, it doesn't prohibit the use and marking of bike lanes next to front-end angled parking. This photograph is a good example of a bike lane with front-end angled parking that is buffered away from the parked cars and in a slightly wider bicycle lane to create a little more space for both parties to operate. The bike guide does suggest that the use of back-end diagonal parking to mitigate the conflicts normally associated with front-end angle parking, and recommends this as a preferable design to front-end angle parking. The bike guide also highlights a number of reasons that back-end angle parking is beneficial to both the motorist and to pedestrians. Bicycle Guide also has a lot of discussion on wider bike lanes and the value of wider bike lanes. It suggests that minimum widths between 6 and 8 feet are necessary and for circumstances where you want to accommodate side-by-side bicycle riding or to create space where a cyclist may pass another cyclist and remain within the width of the bicycle lane. The 6 to 8 feet are suggested minimums to accomplish that, and obviously you could have wider lanes than those, as have been done in numerous cities throughout the United States. The wider bicycle lane accommodating for the higher use also creates a situation where you can improve the comfort for cyclists in the lane by adding some additional buffering between the adjacent travel lanes. Bicycle lane symbols are still required to mark bicycle lanes. The sign reflecting the updated MUTCD is not required. It's an optional element. Similar to the 1999 guide, the parking lane line is an optional treatment that may or may not be used to mark the bicycle lane, consistent with some of the early examples I showed you. There's some discussion on bicycle lane signs that, as shown in this picture, the bike lane end sign and no parking signs are still in the manual. Again, they're optional devices, and if you have concerns about sign clutter, it allows you not to install them. But for circumstances where bike lanes end and it may not be easy to see, or it's around a curve, and there could be benefits to providing that advanced warning, this is an example where you could post bike lane end signs. Some jurisdictions also with state laws or local laws have requirements to enforce no parking in bicycle lanes or no stopping or standing, that it be posted on signs. So in those jurisdictions, it may be necessary to post these no parking signs in bike lanes to allow the enforcement mechanism to occur. So it's always very critical in any jurisdiction you're working in to become familiar with the local laws before you begin bike lane design. Both symbols remain in the guide. The bicycle symbol, the bicycle with rider symbol. You also have the option per the MUTCD to not use either symbol, but actually use the words bike lane. These remain in the guide. There's a little more discussion on the nuance of spacing and placing the symbols. Symbols may be placed anywhere from 100 to 1,000 feet apart, depending upon context. Bicycle lanes on two-way streets are generally recommended to be installed on both sides of the two-way streets in the same direction as traffic. In some circumstances, the guide now actually talks about examples such as you can see on the screen here, where it may be desirable to have a bike lane on a narrower street in one direction and in the opposite direction to mark a shared lane marking. This is typically in a situation where you have a dense network of parallel grid streets, where possibly you have a bike lane pair system. Another example of the context of applying a bike lane only on one side is situations where you have very steep hills, such as this one in Seattle, where it could be beneficial to install a bike lane in the uphill direction, even if the street's a little bit narrow. So in that case, ideally the bicycle lane being installed in the uphill direction allows a cyclist who's moving substantially slower than normal to have additional room to operate comfortably at that slower speed without feeling the pressure that they're impeding traffic and need to pull over and get out of the way. It creates a much more comfortable environment for them to have their own space where they can work themselves up the hill at their own pace. In the downhill direction, it's advisable to install the shared lane marking to ensure that bicyclists are operating the facility in the same direction as traffic in both directions. Bicycle lanes on one-way streets generally should be on the right-hand side of the roadway. However, the guide talks about scenarios where it could be beneficial to have a bicycle lane on the left-hand side, as shown in this photograph. These are typically locations where there may be high volumes of left-turning cyclists, or in situations where it's determined through analysis that you have substantial truck loading on the right-hand curb slide. You have a lot of transit stops, heavy headways. There's a lot of conflicts between cyclists and transit buses. We have high volumes of right-turning vehicles, or where there's concerns or examples such as this where putting a bicycle lane on the left-hand side could mitigate or reduce the incidences of potential dooring. And that applies whether there's parking restricted on the left-hand side or present. Now, when you think about the fact that the majority of motorists today driving around the United States are single-occupant vehicles, single-occupant motorists, that on the passenger side, that door is opening much less. So a mitigation for dooring could potentially be to locate a bike lane on the left-hand side of the roadway. CONTRA-FLOW bike lanes are another new addition to the bike guide. They should always be placed on the right-hand side of the road in the same direction as they would normally be if you had a two-way street with traffic on both sides. So typically a CONTRA-FLOW lane is installed on a one-way street that's made two-way just for bicyclists. As shown in this photograph, generally they should provide a bicycle lane that's separated with a double yellow line to denote that separation between the opposing directions of traffic as you see in this photograph. The opposite direction of the street with traffic may ideally have a bicycle lane, but if not, should be marked with shared lane markings. To make a CONTRA-FLOW bike lane, it's also necessary and important to consider the intersections. Typically, they should all have do not enter signs for the motorists, so it's important to add an exception for the bicyclists so that their movement is legal. It also may be necessary to evaluate traffic signals. In some cases, there may be no traffic signal that faces the CONTRA-FLOW direction, so it may be necessary to install a signal such as this bicycle signal, or to reorient existing traffic signals so that it's visible to that cyclist in the CONTRA-FLOW direction. This guide also now talks about buffered bike lanes and their benefits of increasing safety and comfort for the bicyclist, and it allows the option to place the buffer between the bicyclist and the parking lane, as I talked about earlier, to address dooring concerns, or to add additional separation between the passing motorist and the bicyclist to increase their comfort. There are two examples shown in the photograph of those different scenarios. Bicycle lanes at intersections. This section, the discussion's been increased quite a bit from the last guide, but it's based on these general principles of minimizing free-flowing vehicular movements that cross the bicycle traffic flow, that you consider, as shown in this graphic from Chapter 2, typical maneuvers that a cyclist may make to make a left-hand turn. There's generally 3 ways that a cyclist would make that maneuver. Good design also provides adequate guidance to both the bicyclist and the motorist approaching the intersection and through the intersection. That everything that's out there should be direct and logical, and that all traffic signals should accommodate not only the motorist, but should accommodate fully the bicyclist in detection and timing. We'll discuss that more at the next webinar. You also have the option to use dotted or solid lines, and a lot of that, again, is reflective of your state and local practice and your state and local laws. Bike lane widths at intersections may vary. They may be as narrow as 4 feet between turn lanes and adjacent through lanes, but ideally they would be wider. Bike lanes between moving lanes of traffic should be wider, as shown in the example at the right. Also, per the guidance, they may be colored green. Solid lane lines, as Nick discussed earlier from the MUTCD, discourage a motorist from entering or crossing the line. Dash lane lines encourage crossing or merging. And these lines, these designs should be used to emphasize the design objectives of your local community. The guidance discusses, and this is as similar as the last guide, you have some flexibility in the length of dotting or dashing that you do on the approach to an intersection. That varies anywhere from 50 to 200 feet, and it may be a decision that's based on the prevailing motor vehicle speeds and the land use context. So in a more urban area, very dense street good, low speeds, the dash spacing may be smaller in your local community, where if you're on a suburban highway, it may be more desirable for that dotted line to be much longer. Solid lines should normally be marked solid across alleys and driveways. It's not necessary to dot them at all of those. It's, again, a context decision. If you have high volumes of traffic turning into driveways and they're more equivalent to a street, it may be desirable to dot those in those scenarios. Right turn lanes, again, the bike lane may be dotted, may be solid all the way to the intersection, or it may be dropped completely. Generally, the guide speaks to maintaining bike lanes up to intersections and not dropping them, and it discourages the striping of right turn lanes and through and option lanes are called through and right turn lanes, where you would typically drop a bike lane in that situation. The decision of whether to make it solid or dotted is really a context, again, of the volume of turning vehicles, whether there's bus stops, your state and local law. An important element of these designs is the inclusion and incorporation of the right turn lane yield to bike sign at the beginning of the right turn lane. For left turns, there's also some additional discussion about providing for left turns for cyclists in the provision of their own bicycle lane, their own space. Again, the same principles of width apply, but it's again a context decision of where you have higher volumes of left turning cyclists or a T intersection or a particular movement that is advisable to accommodate. And here's two examples where they have their own space for a left turn only lane on the right hand side, and then the picture on the left hand side actually creates a little bit of a buffer. So you have situations where a cyclist is stopped and you have traffic that's moving to their right, which may be at higher speed. It could be desirable to incorporate a buffer in those design situations. Dotted lines are also discussed as being allowed to mark through intersections. This can be particularly beneficial if you have large intersections or geometry, such as the photo at the left, where the roadway is curving or it's complicated by a number of multi-leg intersections, and it's otherwise can be confusing to maintain your line of travel through the intersection. The dotted lines are allowed through intersections and encouraged. And the use of color and or symbols is allowed in the guide per this, as you can see in the example on the right. Here's another example of the use of dotted lines. And in this instance, dotted and colored lines are used to help clarify the space of the roadway, where motorists should be, where bicyclists should be. And in this case, it helps align them as they cross the streetcar tracks at an angle where they reduces the likelihood of a bicyclist crash. Dotted lines and colored pavement combined, the option is there to actually dash the green to match the skip spacing of the dotted lines as shown in this photograph. Colored green may also be used as a standalone in bike lanes or anywhere symbols are used to silhouette the bike lane symbol to increase its conspicuity to the approaching motorist. And lastly, bus stops. It's recommended that, especially higher volume bus stops, that bike lanes be dotted through the entire length of bus stops, whether they be near side, far side, or mid-block.
Okay, thank you, Bill. This is Nick Jackson again, and I'm going to talk about a new section in the guide that focuses on retrofitting existing streets and highways for the accommodation of bicycles. This is a very important section because we recognize that it's not feasible or even desirable to widen roads to accommodate bicycles. So this new section talks about specific strategies to reallocate space for bicycles. So there really are two basic strategies. One is the reallocation of roadway space. That includes narrowing lane widths, removing travel lanes or parking lanes, or reconfiguration or removal of on-street parking. The second key types of retrofits on existing streets or highways involve construction improvements, and that looks primarily at how do we improve the surface of the roadway for bicycle performance, including drainage grates and other structures and surface issues. So a road dive is a common term for reallocating road space, and there are two primary types of road dives. The first type of dive is to reduce travel lane width. Travel lanes can be narrowed, and the space taken from travel lanes can be used to create space for bicycles in the form of bicycle lanes on streets. The next strategy of a road dive is actually to reduce the number of travel lanes. The most common type of road diet we talk about is going from a 4-lane roadway, 2 lanes in each direction, to a 3-lane roadway, often with a center lane that can be used for turn lanes or to provide refuge for pedestrian crossings. The AASHTO Bike Guide is actually the first AASHTO publication to talk explicitly about road diets and some of the strategies for implementing road diets, and provide these basic guidelines looking at the volumes of vehicle traffic on a roadway, again for a typical 4-lane roadway, and what volume thresholds make good candidates for road diets. So here you can see the range of values that are provided in the guide to help give a rule of thumb. Now, it's very important to note every roadway that needs to be reconfigured should be looked at, an engineering analysis should be conducted to determine what's feasible in terms of reallocating that space. These are general accepted rule of thumb for that approach. So this is just, again, a couple examples. This is a before and after photograph of a road diet. On the top, you see the road before, 2 travel lanes in each direction. On the bottom, you can see the after. Now we have 1 travel lane in each direction. The space taken away has been used to create a bicycle lane in each direction, as well as a center turn lane. Another example of a road diet is a situation where you have an unbalanced number of lanes. And again, determining based upon traffic engineering analysis, this may be appropriate in many areas. So this is an example of a bridge where on one side you have 1 lane approaching the middle of the bridge, but you have 2 lanes approaching the intersection on either side. And the unbalanced lanes work from a traffic engineering perspective and allow the creation of space for bicycle lanes. This is another example of a road diet. Actually went from 4 lanes to 2 lanes. Travel lane was removed in each direction, and in this case, the excess space was used to create a dedicated bike lane as well as a buffer. And as Bill mentioned earlier, that buffer can be very useful, especially in situations where you have differing speeds. Here we have significant slope. We have bicyclists traveling at different speeds, and the buffer and the wide bike lane can help accommodate those uses. Again, another example of just simply removing a travel lane to create space for a bicycle lane. Here again, the extra space is used to create a buffer, and the buffer can be an important tool to increase the comfort of bicyclists, especially in roadways with higher traffic speeds and higher volumes of traffic. Another type of road diet is to repurpose travel lanes. Here, travel lanes are converted to shared bike and bus lanes, and that's another technique to reallocate road space to increase accommodations for bicyclists. And then the last technique is to remove a parking lane. This is an example of a street. This is Mass Ave in Boston. Parking was removed on one side of the street to create space for bicycle lanes to provide important continuity between jurisdictions. And this was a very good improvement to increase the level of service for bicyclists tremendously. So just kind of to summarize, there's a lot of discussion on road diets, and I think what's important about the guide is that it really talks about the benefits from a very broad perspective. It's not just to create space for bicycle lanes, but the road diet has the benefit for other road users as well, in terms of lowering speeds, traffic calming effect, reducing crashes, but also improving conditions for pedestrians. As I showed earlier, the space can be used to create medians to improve pedestrian crossings. Also, operations can often be improved for motorists by creating space for dedicated turn lanes and reducing rear-end crashes. The other technique that I mentioned is simply narrowing travel lanes. And very important point to note about the AASHTO Bike Guide is that it does cite the extensive research that's being done into the lane width, and specifically mentions narrowing travel lanes on arterials to 10 feet. This is acceptable and a useful tool, again, for accommodating bicyclists, but also does not negatively impact safety for other users. But it's a very important strategy that is explicitly mentioned in the AASHTO Bike Guide. You'll also want to note here that you can see the previous lane widths. You can see the grinding the lanes there. The lanes were removed adjacent to the center turn lane in this photograph. In addition to grinding lanes, another a good way, a good time to look at reassessing road spaces during resurfacing. This is a roadway with bicycle lanes that were achieved as part of the resurfacing. Here, of course, the benefit is you get a nice, smooth riding surface. When you do grind existing lanes, you want to be very careful that it's done well, that you don't create safety problems for bicyclists with uneven pavement. And then finally, as Bill mentioned, it's very important to think about the edge conditions for the bicyclists. On the left, we see a picture where actually an existing gutter pan has been overlaid with asphalt, and now you can see the surface is deteriorating. And this is in a position for bicyclists that could potentially cause a serious trip or a fall. On the right, we can show a situation where an entire gutter has been removed and a bicycle-safe drainage grate has been installed. And again, it's important to refer back to the dimensions earlier that Bill discussed when considering these types of improvements. Okay, I'm going to turn it back over to Bill Schulteis to complete the presentation.
Okay, so this review, there's obviously a lot of content in the guide. We didn't discuss bike lanes at roundabouts and bridges. We're going to get into those scenarios a little bit at the next webinar. But again, the same principles of width and buffers apply in those scenarios. But I think it's important to understand, back to the beginning of the conversation, that this is a guideline. It's really not possible to cover all situations, and that there's a lot of unique situations. So one situation that you could look in the table of contents and look up is, how do I terminate a bike lane? You wouldn't find that heading in the guide. It's not explicitly in the guide as a topic. That said, there's a lot of good guidance in the guide, and I'm going to walk you through how you apply the principles of the guide in the context of what is a very typical situation, but frankly doesn't have a typical answer. And this is the other aspect that you need to remember with AASHTO is it's written by again, a state DOT organization, AASHTO, a compilation of cities, states, federal government, and it's a guide that's meant to apply to the whole country. So when it comes to terminating bike lanes as one example, it's really kind of there's a lot of variations in how communities do this. And it may vary from one city to a state, and it's very context-based depending on the type of volumes you have of traffic and speed. And whether there's parking or no parking. So again, there's a wide variety of situations where even a simple thing like terminating a bike lane may come up. So in this example, we have two pictures where a bike lane may terminate at an intersection or it may terminate midstream, shown on the right. But thinking back to the principles of the guide, is first and foremost, is it visible to the motorist and to the cyclist, or is it likely to be a surprise? The first tool of good design is to try to not terminate these things where they're out of view or they would come upon either user as a surprise. In those situations where you can't see them, or it's advisable in those situations to have advance notice that the bike lane ends. At the point of termination, you have another follow-on decision. Should you mark it with shared lane markings? In many cases, it may be a good idea to do that. The other context is lane width. So something that was developed, for example, in the city of Boston, was in situations where bike lane terminated on a wider lane, 14 feet or greater, that's generally considered to be a very shareable lane width. And so in those situations, a share the road sign is applied at the termination of the bike lane. And in certain circumstances, a shared lane marking accompanies that for a certain distance from the termination of the bike lane. The other situation you may have is the bike lane terminates into a narrow lane, a lane that's less than 14 feet. In those situations, again, it's a situation where it's not really safe for a bicycle to operate adjacent to a motor vehicle. It's not shareable. In that case, it makes a lot of sense to apply the bicycles may use full lane sign. And again, they may or may not be marked with a shared lane marking to emphasize that transition. So again, this is one example of many. And we'd like to use that just to illustrate the concept of applying the principles of the guide that are explained in the guide to a particular scenario that you may have in your jurisdiction. So we're going to go ahead and turn it back to James, and he's going to take questions, and he'll, I think he's been receiving the questions online, and he's going to moderate this discussion by restating the question, and Nick or I will answer the question.
Thank you, Bill and Nick. I appreciate that. Yes, we will begin the Q&A session now. Did Jennifer join us as well?
I think she actually won't be joining us today.
Okay.
Just Nick and I.
Well, I've already gotten several questions that we can go with, and if you have any questions that you have not typed them in yet, please do so. We will try to get to them, but we do have a lot of questions, and if we run out of time, I'm sorry. But to start, does the guide provide any way of raising minimum design credentials? Oh, wait. Never mind, I didn't get all that one. Forget that question, sorry. In some areas with wide bike lanes, motorists use them as motor vehicle travel lanes. How can motorists be discouraged from using wide bike lanes?
It's a great question. With the guide, cautions when you get into bike lanes that are wider than 7 feet that is a possibility. It's not a certainty, and again, it's a local concern based on observations in your community of whether motorists are using wider bike lanes as a travel lane. So the guide suggests in those situations where it's desirable to have a wider bike lane for numerous reasons, you may in that case consider adding a buffer, adding additional bike lane symbols, adding signs, and that's separate from the issue of increasing enforcement to discourage that activity. So there's quite a few strategies that can be deployed if you find that is occurring in your wider bike lane. But generally I'd say that the bike guide encourages and supports wider bike lanes in general to improve the cyclist safety and comfort.
I'll just add to Bill's comment there that if the concern, again, is that the wider bike lane may be perceived as being a parking lane might facilitate that, the addition of a buffer can also further identify that space as something different and reinforce it as a bicycle lane.
Okay. Do bike lanes only in one direction on two-way streets ever cause confusion, such as with bicyclists using a lane in both directions?
Based on research of shared lane markings and bicycle lanes, they're not foolproof. The research has shown that some cyclists may still use either facility the wrong way, but generally research is pretty clear that when you add a bike lane or a shared lane marking that you reduce the incidences of wrong way riding from a baseline condition of no marking for bicyclists in particular. That's why the guide recommends in situations where you have a bike lane on a two-way street but only on one side, so like a climbing lane for example, that it also be complemented by a shared lane marking in the other opposite direction.
Okay. Is there a threshold for grade that would trigger the desire for an uphill cycling lane?
The guide is silent on that. It doesn't say consider this at 5% slopes, for example, just throwing a number out there. It doesn't say that. Again, it's the purpose of the guide is to put out the concept, and then it's based on local practice. You know, the streets of Seattle, the people living out there are used to very different slopes than people living in, you know, Florida, Tampa. So person's hill in Tampa, their perception of what a steep road is very significantly different than a person living in Seattle, for example. So I think that's the right approach for the guide, to just put the concept out there so that it's defined how to do it correctly, and then the actual threshold should be defined at a more local level.
In one of the slides, you had a "Do not enter except for bicycles" sign. Is the accept bicycle sign in the MUTCD?
Exception signs are allowed in the MUTCD, and it is a device. It's not explicitly in the MUTCD for that exception, but the National Committee has approved putting that specific exception plate into the next edition of the guide. But that said, it's still an allowed sign, just consisting of words that an agency has the ability to put up.
Is there any sort of land use context that would make dashing an entire length of a bike lane desirable?
One that comes to mind might be a downtown area where there's a lot of surface parking lots or garages, where potentially you have a garage every 50 feet, every 100 feet. That might be a situation that might be considered. Also, in the presence of the NACTO guide is one to look at, is this idea of an advisory bike lane where it's dashed continuously throughout its length to allow, to first encourage motorists to stay out of it when there's not opposing traffic, but then to allow them the option to come into the bike lane. Another context is, very suburban areas. We showed that in one of the pictures, where you've got a lot of traffic that may be turning. It's more or less going straight, but you have intersections that are close with driveways close by. You may want to have longer stretches of bike lane that are continuously dotted.
When there is no right turn lane, do bike lanes encourage drivers to pass stopped cars on the right, increasing the chance of a right hook crash?
Thus far in the research, there's no evidence that that is something that's occurring because of that design.
Have there been any issues with slicker pavement due to the green paint?
No, in general, there are not been any reported issues that they're aware of. I think that consideration should be that the paint should be used non-skid, similar to other markings.
And in the interim approval for the use of green, they speak to using materials that are consistent with pavement markings throughout the MUTCD, and colored lanes, because colored lanes are actually allowed for other purposes in the MUTCD that are non-skid and depending on your situation, are reflective at night.
Okay. How do you justify removing lanes to create bike lanes when the public is typically resistant?
That's a great question. I think that really it's going to be different for different communities. Some examples that I showed from Boston were situations where bicycle crash history was a significant part of the discussion. There were documented issues of bicycles involved in crashes, and that was one of the major drivers. I think it's also important that the process involve a really close redesign of the roadway. It's often an opportunity to improve operations for motorists by the provision of turn lanes, really thinking carefully about how the road is designed. Many roads often do have excess capacity, and that can be discovered through traffic analysis. But it's important that it be done in a very deliberate and detailed design process that looks closely at the bicycle movements as well as the motorist movements. So a really thorough process is probably the best course of action.
Okay. When using the term share the road, does that mean nose to tail or side by side?
In the context of the example I showed at the end, that's the more traditional share the road understanding of a motor vehicle being able to pass a cyclist in the same lane without having to change lane. That's why we spoke about 14 feet. And actually in the next webinar, we're going to detail that out a little closer. We just thought it would be a little too much to try to get into the other on-road devices today, so we focused on bike lane.
With a 14-foot shared lane, does that also include a 2-foot gutter pan?
We'll again talk about that in the next week, but the next webinar. But it's a situation where that really shouldn't probably be considered part of the shared lane, unless that gutter is smooth to the asphalt or the concrete, that there's not really any vertical gap or drop off at the gutter line, so that it's actually functional. In most situations, that gutter line may not be really functional. From my observations of these scenarios around the United States.
Are there any specific guidelines that talk about adding a bike lane down a suburban residential street?
I think there one context that is in this chapter is the discussion of bicycle boulevards. And that can be a location where a bike lane may be considered appropriate for a short stretch. In general, the guide is focused on bike lanes on your major streets, on your collectors and arterials. Another example would be a situation, again, where you have a street system where you have a residential street that's providing a parallel facility or providing continuity for another facility that provides an important connection, so it can be useful to provide a continuity in the overall bikeway network.
Another tool that might, whoever asks the question might want to consider is the use of the bicycle level of service modeling, because there's a wide variety of suburban residential streets that may have, they might be 50 feet wide or really wider than that, just 2 lanes with sporadic parking, and they may be just fine, comfortable for cycling. That said, those streets may vary in volume from 500 cars a day to 10,000, and the experience of that cyclist would vary dramatically depending on those different contexts. So it may be a situation where that's a good example to apply that highway capacity manual, the bicycle level of service modeling, to help you make that decision of the value of adding a bicycle lane in that context.
Great. How do you deal with contra-flow bike lanes and intersection signage to warn motorists to stand to their right?
Forgive us for a second. We're trying to visualize that question. The main issue, really, if I understand it correctly, is keeping the motorist out of the contra-flow lane for the cyclist to preserve the integrity of that opposite direction movement. So I think in that scenario, there's a couple. The guide discusses a number of options. First and foremost is the double yellow center line, which is widely understood by roadway users to not cross it. It's an enforceable pavement marking that the police can help you with. The second couple things and strategies that are talked about is having a wider bike lane and possibly adding a buffer. And that buffer, if you get a bike lane that's up to at least 7 feet wide, the guide actually talks about physical separation with a curbing or a flexible post, which then would further keep the motorist from intruding on the contra-flow bike lane. The guide says 7 feet as a minimum in those situations for the vertical separation, so that there's enough space for a cyclist to be able to pass another bicyclist in that contra-flow situation, that they're not squeezed too tightly and narrowly at a narrower dimension.
Okay. How have you successfully resolved the issue of eliminating parking for new bike lanes, as this conflicts with land use owners against the development of bike lanes?
I think the guide does acknowledge that removing parking is one strategy to create space for bike lanes. As you acknowledge, it's it can be a very complex discussion, as on-street parking can be desirable for other uses. So I think a good process really looks at all those issues, and I think one of the primary reasons that I've seen it been successful is, again, looking at the safety of roadway users, and where that can be clearly demonstrated as being in conflict. Then that's a situation where where parking can be considered to be removed. In many cases, when looking at bicycle networks, you have a redundancy in your street network. You might have a parallel route on one side or the other that can work well. In many cities, we do not have that redundancy, and there is only one street that provides unique access for travelers. So again, all those situations and all those contexts need to be looked at the same time. Those can be some of the considerations that can lead to consideration of removing parking to create space for bicycles.
Is the use of share the road signs not applicable for lanes that are less than 14 feet wide?
Again, I'll discuss this some more in the next webinar, but it's not that they're not applicable, and they may, in fact, local jurisdictions may decide to use that sign in that scenario. But this guide provides, we have a new tool now, the bike may use full lane sign, plus the shared lane marking that didn't exist in the past. And we think the guide discusses the context and the different operations of a different lane width to help local agencies make that decision. You know, one factor is how much traffic is there. A 10-foot wide lane on a rural road with 200 cars a day, plenty wide enough for sharing. That same 10-foot road with 10,000 cars a day on it is not going to be a great experience for cyclists to share, and it's not really going to be a comfortable share of the road environment. So you're seeing in those situations recently around even this D.C. area, Maryland State Highway Administration, for example, has been posting the bikes may use full lane signs in situations where there's higher volumes of traffic in narrower lanes.
Okay. Does the new bike guide mention anything about using rumble strips to separate bike lanes and motor vehicle traffic? And is that even a good idea when motor vehicle traffic is moving fast, say above 45 miles per hour?
The guide speaks about rumble strips. We're going to talk about it a little bit more again next webinar when we talk about shoulders, because it's typically more going to be a situation you encounter when we're talking about suburban, rural roads with shoulders, where rumble strips have been documented to be an effective strategy to reduce motorists from running off the road and having crashes. Likewise, rumble strips have also been shown to be a crash hazard to cyclists. So the guide does offer guidance on how to reconcile the safety benefits to motorists with the potential challenges to cyclists. So generally, I think I'll save the rest of the answer for the next webinar when we get into more detail, but the guide does speak to it in the context of paved shoulders.
Okay, in this particular instance, one local advocate group is pushing for bike lanes on a road that also has a trail along one side. What would AASHTO recommend?
Well, I think a couple things, and maybe I'll start. I think that's something that definitely is something that is appropriate to be considered. As we know, trails can often be victims of their own success, and they can be very crowded, very congested, and in many cases, many bicyclists may choose and may find more comfort in an on-road situation. Again, especially where that trail is heavily used by a variety of users, whether it's pedestrians, rollerbladers, or other types of users. Providing a bike lane can be a good accommodation for many bicyclists.
It's a situation where the existing guidance in the AASHTO guide suggests that vertical posts such as bollards should not be located in bike lanes, adjacent to bike lanes. And that's for good reason, to make sure that say you have a 5-foot bike lane you're going to put flex posts on it between the bike lane and the adjacent travel lane, it can create a potential crash hazard to the cyclist. Now, if I'm understanding that scenario correctly of a bike lane next to a trail, it's a slightly different situation where maybe the bike lane is to the left of a trail on the right. It may very well be appropriate to add some flexible flex posts to keep a separation between the two. And while the guide says they should not be placed, it doesn't say they shall not be placed. And it's a case of applying engineering judgment and the flexibility of the guide for your particular situation. Again, I'm not recommending that as a treatment without seeing that situation, but I'm illustrating that as an example of the built-in flexibility of the guide to come up with creative solutions for unique situations.
How do you resolve the potential conflicts associated with combining a two-way bike lane on one side of the road?
The guide actually doesn't discuss two-way bike lanes at intersections where conflicts would come up. It really doesn't discuss two-way bike lanes as a standalone item. What the guide does do is discuss trails in an entire chapter. And in some cases, a two-way bike lane has some similarities to a side path. So I think stay tuned for the trail webinar, and we can talk about some different design strategies for handling trails at intersections.
Does the guide discuss keeping bike lanes clean, like such as street sweepers or other pickup? I guess in some places the state DOT will not sweep unless they've installed and maintained the lane themselves.
Yes, that's a very important consideration for bicyclists' comfort and safety. And that actually is addressed both in this chapter, the chapter on street design, as well as a chapter dedicated entirely to maintenance practices for bicyclists. So it's addressed actually in both of those places.
If you had 14 feet for bike lane and parking, what would be a preferred configuration? 6 feet and 8 feet, or 7 feet and 7 feet? Or is there another suggestion including a buffer?
Well, I think as a lot of the photographs illustrated, agencies are trying a wide variety of scenarios, and that's why the guide doesn't say any one of them is the correct one or the right one or the standard one. It's going to come down to the particulars of your situation, of whether it may be more valuable to buffer the parked cars if you're in a commercial area, Main Street, with a lot of parking turnover. In that situation, you may want a 5-foot bike lane next to 9-foot parking. You could buffer out the door zone and keep the parking lane narrow to kind of keep cars as far to the curb as possible. That might be the best design situation. You may have a different situation where there's a lot of parking but very little turnover, but you're adjacent to a highway or it's an arterial with high traffic volume and a lot of trucks. So in that case, that space may be better utilized to buffer the bike lane with the adjacent travel lane.
Is there ever a situation where a bike lane could be used for occasional parking, such as a bike lane in front of a church that could be used for parking on Sunday morning services?
The guide doesn't speak to allowing that. It's not an ideal situation. I will say I have seen it in numerous cities around the United States, and typically they're a result of compromise through a public process where parking was in demand for a particular day, a particular location. It may be a park where I can think of a situation in Denver that comes to mind where there's a bike lane adjacent to a regional park and there's not parking on site for the park. So the bike lane is used as a parking lane on Saturdays and Sundays. The rest of the week it's more or less a very, very wide bike lane. Again, so I think it's a very context-based decision, but often it starts, I think, with a compromise, and it's not ideal to have a bike lane flex as a part-time parking lane.
Does the guide address how bike lanes should be marked when approaching a gore area that has a channelization for a free flow right turning movement? For example, at an intersection that a free flow movement onto a ramp to an equal or higher functional class roadway? And how is the channelized island marked with the adjacent bike lane?
Yeah, we actually have examples of that in the guide, and we are going to go through those in the next webinar. Because they relate to a discussion we're going to have about bike lanes as they approach limited access highways and freeways. It kind of ties in. The reason we're also punting it to the next one is it kind of more ties into shoulders and how you deal with shoulders in those situations. A lot of similarities.
Have you ever used shared area lanes with ped and bike? And if so, would you recommend them?
Shared lane marking with pedestrian symbols and bike symbols, if I understand that question correctly. I've seen it in Seattle on an urban street without sidewalks, where to prevent motorists from parking in what is the space that pedestrians would normally be walking on the edge of the road, and where cyclists were regularly using, to enforce it, a parking prohibition there, they had to mark it. And so they used pedestrian symbols with bicycle symbols to maintain that clear space. The guide does not talk about this very unique situation.
Do you have any advice for municipalities that won't put in bike lanes for fear of the liability?
The guide has a discussion on liability, I believe, in the planning chapter and the operations. And I think that generally liability varies by state and local laws, mostly state laws. So I would start with understanding your state laws on tort liability for both the practicing engineer and the implementing agency. Those liability may be different for the different groups. And once you've got that answer figured out, then after that, when it comes to good engineering practice, when you work with engineering professionals, is they have registered. You make sure you're working with a registered engineer, and that the engineering firm that you're working with, and the engineer in particular, that the process of protecting yourself in a liability situation is having good documentation for your decision. That you're following guidance, and that if you deviate from what's deemed standard practice, that you document why that is, that you're deviating. And in most circumstances, that covers your liability.
Does the guide offer suggestions or ideas for how to prevent or reduce wrong-way riders in bicycle lanes?
Well, I think we've already talked about some of the strategies. I think obviously the most important one, wrong-way riding can often be the result of bicyclists seeking a direct route and there being the lack of accommodation of that movement. So providing high-quality facilities in both directions to serve those desire lines is very important. There are also supplemental signs that may be used to indicate bicyclists if they are traveling the wrong way in a bike lane. So those are discussed in the guide as well.
Is there any situation when it would be appropriate to place a bike lane down the middle of a vehicular street?
I think one example we discussed is providing a left turn lane for bicyclists. For example, if you have a bicycle boulevard that's on residential streets that come to an arterial at an offset intersection, that can be a place where it's appropriate to have a bicycle turn lane in the center of a two-lane roadway.
Another example that's gaining some attention is the bicycle lanes on Pennsylvania Avenue. They're sometimes referred to as cycle tracks, and I think you could come sort of a definitional question, but for all practical purposes, they are bicycle lanes that are marked in the center of the street. And what makes them unique is that at all the intersections are signalized, and that conflict with left-turning motorists that cross the bike lanes in the middle of the street are fully controlled with traffic signals on a separate phase.
Okay. One of the last slides shown included a location where a traffic lane was replaced with a bike lane and a buffer lane. However, the slide also showed a bicyclist using the buffer lane to pass the slower bicyclist. Is there anything that can be done to prevent a driver from using the buffer lane for the same purpose?
I mean, if it's a problem, the example we showed was actually an underpass of Massachusetts Avenue, a Commonwealth Avenue underpass of Massachusetts Avenue in Boston. It hasn't been reported to be a problem in that location. That said, if you're in a different situation where the motorists are regularly encroaching on that space and you've got that type of width available, it may be appropriate to have a vertical separation with a flex post or other device.
I think it also speaks to the importance of doing the planning and doing the traffic analysis. And in many cases, if there is, if that's a problem, that may be an issue with traffic as well that can be identified during a traffic analysis phase of the project.
All right, I think we got time for about 2 more questions. Can you discuss the pros and cons for a bike lane between the sidewalk and parallel parking?
Well, that is not recommended in the AASHTO guide of taking a bike lane and just putting it between the sidewalk and parking. Primarily because it introduces a host of issues at the intersections of reduced sight lines between the cyclist and the motorist and vice versa, putting that cyclist in increased danger of a crash. That said, you know, the NACTO guide talks about cycle tracks, and a cycle track is not the same as a bike lane, because a cycle track actually is designed to deal with the intersection by doing mitigation such as bringing the bicyclists out to be more visible, changing the phasing so that they're crossing at different times, restricting parking, just among a couple examples of treatments that are used for cycle tracks adjacent to it. So a little bit of it is definitional and approaching the differences from a bike lane to a cycle track, but behind that definition are important design principles which are different. They're different contexts of how to approach those design situations.
All right, and this will be our last question for today. There's a slide showing a shared bus and bike lane. Are buses expected to move to the left to pass bicyclists?
Yes, in that instance, that would be the expected behavior. And again, it depends upon the width you have available. At a wider lane width, it may be possible to pass without encroaching into the adjacent lane. In narrow situations, it would be necessary to encroach the adjacent lane to pass one user.
Okay, well, thank you very much. That is all the time we have for discussion today. I am sorry if we did not get to your question. Once again, a PDF copy of the slide presentation will be available later today at www.bicyclinginfo.org/AASHTO, and a recording of today's program will be posted in a week or 2. Also, we will be conducting 4 more webinars on the Bike Guide over the coming months. I encourage you to join us for those. Finally, I want to remind you that a very brief survey will appear on once the webinar is ended. Again, we very appreciate you taking a moment to complete it. Thank you again to our speakers, Bill Schulteis and Nick Jackson, and thank you to all of you for attending today's PBIC webinar.